Okay, so Unit 4, last unit of the semester. Yay! We have two more systems that we're going to cover, the urinary system and the reproductive system. Especially in the male, they're kind of interrelated because they do double duty. They are both for the exit of the urine and the transfer of semen. So expect things to kind of overlap in that way, just so you're aware. Okay, so the urinary system. Urinary system has basically four major parts. You have the kidneys, the ureters, that are the tubing that carry the urine that the kidneys are making to the bladder. The bladder, or the urinary bladder, is a holding cell. It basically holds the urine and keeps it where it's supposed to be until we actually vacate it or we urinate. And then we've got the exit, which is the urethra. So you've got the liver up here, the stomach would be here. The kidneys are actually back here, way in the back. They're actually retroperitoneal. So you know all of the peritoneum and all of the layers of the peritoneum that we've learned? Well, this is actually behind it, almost like you've shrink wrapped these to the back of the abdominal cavity. So they're behind all of those layers of membrane that cover the abdominal organs. So you've got the two kidneys. Notice that they do sit slightly below the ribs. On top of them is where the adrenal gland sits. You've got the renal veins and the renal arteries. Renal is just a fancy way of saying kidney. You can see the abdominal aorta and the inferior vena cava and how they actually go into the kidneys, either draining them or delivering to them. You've got the ureters, like I said. These are responsible for carrying that urine that your kidneys have made to the bladder. Here's the bladder down here. The ureters actually come down and in through kind of the back. What this does is, as the bladder fills, it actually kind of comes back like this, and those two entrances to the ureters get kinked so that there's no backwash. Now, this works really well unless you let your bladder overfill. Once it starts to fill past a certain point, it'll actually open those up again. And when that happens, you can get bacteria from your bladder going up into the ureters, and that bacteria can actually move all the way to the kidneys, causing kidney infections. So, urinary bladder, and then you've got the urethra, like I said, that is the exit. This particular picture is going to be that of a female. And the way that I know that is because the urethra in this picture is very short. Males have a very much longer urethra because it has to go through the distance of the penis. So, looking at a coronally cut kidney. The kidney itself has two areas to it. Okay, you've got the medulla in the middle, and then outside of that, out here, is the cortex. So you've got the renal medulla and the renal cortex. And you know where the medulla starts because of these structures. These structures, if you'll notice, don't go all the way out to the end here, okay? These structures are called renal pyramids. And the reason that they are called renal pyramids is because if you actually take all of the tissue from them out, they do have a pyramid shape. They do look like a pyramid. Hang on, let me get the kidney model so I can show you real quick. Okay, so if you look, this would be the pyramid. Okay, and as you can see, it does have that kind of flat base, pointy top shape to it, which is why they call them the pyramids. So where you have the pyramids is the medulla. From the end of the pyramid out is the cortex. Okay, now out here, your kidney is actually surrounded by a capsule. So if you're dissecting something and you have to get through to the kidney, you actually have to puncture through that. There is that layer on the outside to keep it its own isolated organ. As I said, renal just means kidney. So you've got the renal pyramids in between this tissue here. This is called the renal column, okay? It's not the pyramid, it's that area in between, okay? Now, here, you've got these little pinholes, okay? These are called the renal papillae. So as I'm making urine, I've got to have a way to drain it. So if you look, let me see if I can get it in camera. There. You can see the little pinholes here. Those are the renal papilla. Okay, basically the tubing that's up here is draining into that space that you see right there. So, cortex medulla, where was I? Renal column, renal pyramid, the papilla. The renal sinus is the space that we have in between all of the renal pyramids, okay? So if you look, I've got these kind of connecting tubes. The smaller tubes are called the minor calyx. But as they fuse together to make bigger tubes, like what you're seeing here, I've got two small tubes here, and then I've got this bigger chunk of tube here, okay? That would be a major calyx. And as they all drain into this space that's underneath this artery and vein here, this is actually called the renal pelvis. This is where all of these tubes that you see end up draining into this space here. This is the renal pelvis, okay? So the renal pelvis actually eventually becomes the ureter. See it right here? That's the ureter, okay? You've got the renal artery and the renal vein back here. The vein is going to, of course, be draining the used blood and taking it back to the heart and the lungs to get oxygen again. The artery is bringing the oxygen, fresh blood, but it's also full of waste products. So the kidney's job is to basically filter that blood and get the waste products out. And of course, up here is that adrenal gland with the cortex and the medulla. Okay, the hilum. The hilum is the indention in the kidney. See this indention here? Where things enter or exit from the kidney itself. So the ureter would be an exit, the renal vein would be an exit, the renal artery would be an entrance because it's going in to deliver the oxygen-rich blood and also get filtered to get rid of the waste products. Okay. Yes. All right. So let's talk about the vasculature that's going into our kidney. So our renal artery comes in and it splits. That first split is going to be the segmental arteries. They're going into the different segments. Then that further splits into the interlobular arteries, in between the lobes, okay? As they come up and around, they form an arc. See that? These are the arcuate arteries. And then here, okay, these are the interlobular arteries as well, except they are actually further into the cortex. Now, as they go into the cortex, they're becoming little bundles, okay, of blood vessels that you see over here. There's the arcuate artery, okay? There's that interlobular artery. They become the glomerulus, glomerulus, okay? The glomerulus is basically where I'm going to filter out the waste products. So once I've done that, okay, here's an afferent arteriole. Remember, afferent means arriving. Becomes my glomerulus. It filters, and then I leave via the efferent arteriole. Efferent means exit, okay? Afferent arriving, efferent exit. So this efferent arteriole actually becomes this little bundle of capillaries right here. These are called the peritubular capillaries, okay? Peri, around, tubular, the tube. These two things here are called the distal and proximal convoluted tubule. So peritubular capillary makes sense. It's around the tubules. As it comes down, it becomes this right here, this kind of web network of vessels. This is called the vasa recta. So rectus means straight, vasa, vessel. See how this is pretty straight up and down here, this tube that you see? This is right next to it, so we call it the vasa recta. By the time it goes from the peritubular capillaries into the vasa recta, it's used up its oxygen. It's basically turning into deoxygenated blood, so it gets picked up by the arcuate vein or the interlobular vein. I'm sorry, the interlobular vein to turn into the arcuate vein. So again, going back over here, there's that interlobular vein. Here's the arcuate vein, makes an arc, right? The interlobular vein here and here, okay? That eventually turns into the renal vein that will drain the kidney. We still have the medulla where our pyramids are. We still have the cortex where they're not. We still have the renal pyramids and the renal columns, and out here we would still have the capsule that surrounds it, okay? So, sorry, hang on a second. I left the zipper on my bag open, so anyway. This structure that you are seeing here, this structure here that's in yellow, is actually called a nephron. Okay, just so you're aware. We're going to get into the specifics of it in a minute, but right now I kind of wanted to go through our arteries and veins though. The blood supply going to the kidney is really important. Our major filtration system for our blood is our kidney. That's its primary job. That's what it's supposed to do. Hair. Sorry. Anyway, that's its primary job. That's what its goal is. That's what it's supposed to do. So having the blood go through your kidneys, it happens between 70 and 80 times a day. Your kidneys are really essential. And while you don't necessarily need two of them, you get below 1/3 of one kidney functioning and you're going to die within 4 days. That's how important their job of filtering your blood actually is. Okay? All right. So let's look at the model. This is not the model that I just showed you. Kind of like this one better, but we'll see. Maybe I'll use this one for pictures for the practical. Still the same parts and pieces. Nothing else has really changed. You've got the renal artery, you've got the renal vein, you've got the ureter, there's the renal pelvis. You've got the renal medulla. Past my pyramid is the renal cortex. Out here is the capsule. You've got the segmental artery and vein. You've got the arcuate artery and vein, making the arcs. You've got the pyramid and the column, the papilla, the minor calyces. You can see where they merge into a major calyx. The collecting duct is part of that nephron, and that'll make sense in just a bit. These are also those interlobular arteries and veins. All right. I think that's everything. Yeah. Hello. All right, so again, renal artery and vein, the segmental artery, segmental vein, interlobular artery, interlobular vein, the arcuate vein, and the arcuate artery. Okay? Now, the nephron. The functional portion of the kidney, the thing that actually does what we need as far as filtration of the blood, is the nephron. That is the functional portion that actually does the work. So the nephron itself has specific parts and pieces, and we basically have two different brands of nephron. So you've got nephrons that are in the cortex, but they're dipping very, very far down into the medulla, okay? These are called juxtamedullary nephrons. In other words, they are really extending down into the medulla. The ones that are not doing that, they're kind of superficial in the cortex, those are called cortical nephrons. As you can see, we've got kind of the same basic structure to them. We've got this thing here, kind of a squiggly part, this coming down, this going up, this coming down, this going up, another squiggly part, and then this tube here, okay? So this right here is called the renal corpuscle. So again, renal means kidney. It's made up of two things. That little bundle of capillaries called the glomerulus, and then this piece of tissue that actually surrounds it almost like this, okay, called Bowmans capsule. So, hang on a second. Well, I'm getting ahead of myself. That Bowman's capsule is attached to this squiggly here. You can see it right here. So we learned directional terms in A&P 1. Proximal meant close to, distal meant further away. Now, when we were talking about the limbs, we talked about proximal being closer to the torso and distal being further away. So in this case, proximal is closest to Bowman's capsule, distal is furthest away from Bowman's capsule, okay? The other word that is used is convoluted. Convoluted means twisted. So if somebody has a convoluted mind, you say that they're twisted in the head. So proximal convoluted, close to Bowman's capsule, it's twisted, and it's a tube. So it's the proximal convoluted tubule. So this first thing that's coming off of Bowman's capsule right here is the proximal convoluted tubule. Because it's closest to Bowman's capsule, it's twisted, and it's a tube. Now, after the proximal convoluted tubule, we have this thing that dips into my medulla. This is called the loop of Henle, okay? Guess who discovered it? So the loop of Henle, if I'm harvesting from this blood vessel and bringing it through my proximal convoluted tubule and it hits this tube, which direction is it going to be going? Down, right? So same here, if I'm harvesting here, taking it through my proximal convoluted tubule and taking it to this tube here, this would be the descending loop of Henle. If you follow the path of the filtrate that is going to be made into urine, this is the descending loop of Henle. Now we get to the end of that and start up, right? Get to the end of this and start up, it's not descending anymore, right? So this is the ascending loop of Henle. But I want you to notice something. There's kind of this thin area here and this thicker area up here. You can see a difference in the circumference of the tube. So this is the thin ascending loop of Henle, and this is the thick ascending loop of Henle. Now notice, I get all twisty-turny again over here. But if you're measuring distance from the renal corpuscle, if I were to straighten this out ever so much, this would be a lot further away, because I mean, it's not directly connected to it, from this renal corpuscle. So this is not the proximal convoluted tubule, it's the distal convoluted tubule. It's further away from the Bowman's capsule. And then this dude right here is called the collecting duct, because if you'll notice, I have what looks like other places for other nephrons to attach. So when I'm making the urine as a nephron, I dump it into the collecting duct that collects from quite a few nephrons, so that by the time it's done, remember our renal papilla, those drainage points, they're right here. It drains into the minor calyx in the kidney. So looking at the model, I've got Bowman's capsules. You can see them, right? I've got the proximal convoluted tubule. It's right next to Bowman's capsule. I've got the descending loop of Henle. I've got the ascending loop of Henle and the collecting duct. Here, Bowman's capsule, proximal convoluted tubule, descending loop of Henle, ascending loop of Henle, distal convoluted tubule, because it's all twisted, and then the collecting duct, okay? Literally, if you can just follow the tube, you'll know what part you're looking at, okay? So here are all the labels. When you're labeling a model and it's supposed to be for people, it's kind of hard to put all of those words on something this small. So I use the abbreviations, but in this slide, you can see what the abbreviations actually mean. Okay, so let's look really, really closely at the renal corpuscle that's made out of my Bowman's capsule and my glomerulus. Actually, I'm going to make that part 2.